All right, this is the second lesson in ellipses, and we're going to look at translating them in this lesson. So they won't be centered at zero anymore necessarily, and we're going to take a look at what that does to our equation, okay? So we're looking at vertical and horizontal translations. For an ellipse that's centered, it's at HK, so that's the point HK. So the formula we get looks like this: x minus h squared over a squared plus y minus k squared over b squared equals 1. Now the a and the b can be switched. So if it's a horizontally elongated ellipse, the a squared is under the x term, and if it's a vertically elongated ellipse, the a squared is under the under the y squared term. Okay, so this gives us a mapping rule that we can use to translate the points, the critical points of the ellipse. So we can look at the vertices, we can look at the endpoints of the minor axis, and we can look at the foci, and we can use a mapping rule to come up with the coordinates of those points. So if we think about the mapping rule from the other times that we've used them, where we looked at translations, horizontal and vertical translations, we end up with a mapping rule of x plus h and y plus k. Okay, and we'll use that mapping rule to locate the foci and the other critical points. So our first example is x minus 1 squared plus y plus 3 squared. Sorry, x minus 1 squared over 9 plus y plus 3 squared over 16 is equal to 1. So the center is at 1, negative 3. Okay, so you're changing the sign on each of those terms each time. Okay, our mapping rule will be that the xy values, so our critical points, map onto x plus 1, y minus 3. Okay, our a value is, because the 16 is larger than 9, our a value is along the y, so this is a vertical ellipse, and our a squared is 16, which gives us a is equal to plus or minus 4. And our b squared here is 9, so b is equal to plus or minus 3. And let's calculate c right away. So c squared, remember, is a squared minus b squared. So it'll be 7. So c is equal to the positive and negative root 7, which is approximately 2.6 when it comes to graphing those points. So now we can take a look at how to use those values and plot our ellipse. Okay? If you think about where our vertices originally would have been, because A is 4, our vertices would have been at 0, 4 and 0, negative 4. But if we apply the mapping rule to them, and the mapping rule adds 1 to the x and subtracts 1 from the 3, this point will map onto 1 and 1. Okay, adding 1 and subtracting 3. So you can try that with this other point. So you can press pause at any time and try translating the other pieces, and then hit start again, hit play again when you want to check your answers. So for our second vertex will map onto 1 and negative 7. If we look at the endpoints of our minor axis, they would have been at 3 and 0 and negative 3 and 0. And again, we can see what they map onto. And they'll map onto 4 and negative 3 and negative 2 and negative 3. And our foci originally would have been, excuse that, our foci originally would have been at 0 and root 7 and 0 and negative root 7. And those will also use the mapping rule for, so we'll get 1 and root 7 minus 3 as one of the foci, and one will be negative 7 minus 3. Sorry, I didn't write that correctly. Negative root 7 minus 3. Okay, so when we plot those now, we can look at our vertices first. Actually, let's look at the center first. That'll be a little bit easier. I'm going to just move the graph up beside these now. We said that the center of this was going to be at 1 and negative 3. So over 1, down 3. There's the center of the ellipse. Our new vertices now are at 1, 1, and at 1, negative 7. 3, 6, 7. And our endpoints of the minor vertex are 4 and negative 3, and negative 2, negative 3. So there's the outline of our ellipse, so we can sketch it in. And then we can label our foci as well. They are at 1 and root 7 minus 3, which is approximately negative 0.4, and 1 and negative root 7 minus 3, which is approximately negative 5.6. And now we have sketched the vertex, the ellipse, we've labeled our foci, and we have found the coordinates of the foci as well. Okay, so that's important to have all of those for a question like this where we're asked to locate the foci. Okay, this next example, we have an ellipse again, but it's not in standard form yet. So we want to get it into standard form so that we can graph it easily. So just like we did in our first lesson, we're going to have to do a little bit of math to this. We want the right side of the equal sign to be 1, so we'll divide each term on both sides of the equation by 64. When we do that with this part, we end up with a 1. And when we do that with this part, we end up with a 16. So the equation in standard form now is x minus 3 squared plus y plus 2 squared over 16 equals 1. Notice that under the x squared term, we don't have anything written, and I prefer that you write it with nothing written, but what you can do is you can think of it as being over 1. So then it's easy to figure out your A, B, and C from that. Okay, so again, this is one of those vertical ones because the value under the y squared is higher. So our A value, or our A squared, is 16, and our B squared is 1. So now, first step is to look at what is the center of this ellipse going to be. And looking at that equation, we can see that the center is going to be positive 3, negative 2. We can also then write our mapping rule, and it will be x plus 3, y minus 2. Our vertices, looking at the equation, we can see that originally they would have been 0, 4, and 0, negative 4, because the A value is plus or minus 4. And applying our mapping rule now, we'll get the point 3, 2, and 3, negative 6. For the rest of these, you might want to come up with the points on your own and do the mapping rule and sketch it and press pause as you do that, and then come back, hit play, and see if you are correct. So the endpoints of our minor axes, because the B value up here is 1, so that means B is plus or minus 1. So our points would have been 1, 0, and negative 1, 0. And those are going to now map onto 4 and negative 2 and 2 and negative 2. And our foci. To do the foci, we need to, excuse that, we need to first of all calculate the value of c. So our c squared, remember, is going to be a squared minus b squared, so it'll be 16 minus 1. So c is going to be the square root of 15, positive or negative, the square root of 15, which is approximately 3.9. So our foci originally then would have been 0, and I'm going to use the decimal approximation just because it's easier to graph, and 0 and negative 3.9. So once we apply the mapping rule to those 2 points, we end up with 3 and 1.9 and 3 and negative 5.9. So now we have the 2, 4, 6 points that will help us to graph and label our ellipse. I'm going to just move the graph here a little bit. And so we are centered at 3 and negative 2. Our vertices are 3 and positive 2 and 3 and negative 6. Our endpoints of our minor axis are at 4 and 2. So at 4 and 2. So you can see this is going to be a long, skinny ellipse here. And our foci are at 3, 1.9. So just a little bit, just on the inside of there, and 3 and negative 5.9. This is of interest to note that the further, the skinnier ellipse has the foci closer to the vertex. Round or fuller ellipse has the foci moving in towards each other. Okay, for the next question that we're going to do, we're going to have to remember some skills from factoring so that we can switch equations of ellipses into standard form. So we're going to review what perfect squares look like. So if you think about x plus 3 squared, remember that's x plus 3 times x plus 3. So when we multiplied that through, we ended up with x squared plus 6x plus 9. Notice that to get that x term, or that middle term, is 2 times 3, and that last term is 3 squared. Okay, and the skill that we're looking at that we need to know how to do for this is called completing the square. So that means adding the correct number at the end turns something into a perfect square. So there's a neat little trick for that. If we look at the example, if we had just the x squared plus the 6x, we would take half of that because the 6x is 2 times 3. So we would take half of that 6 and we'd say, oh, well, that's 3. And half of that squared, so the 3 squared gives us the 9. So if we follow those steps with these, half of 8 is 4, and 4 squared gives me 16. We can do that here. Even though there's subtraction, remember that a negative times a negative gives us a positive, so we'll end up with still adding something here, but half of 12 is 6, and 6 squared is 36. Half of 5 is 5 over 2, and 5 over 2 squared gives me 25 over 4. Okay, so if we look at these in order again now, x squared plus 8x plus 16 is equal to x plus 4 squared. X squared minus 12x plus 36 is x minus 6 squared. And x squared plus 5x plus 25 over 4 is equal to x plus 5 halves squared. So completing the square is figuring out what number you need to add to the end to make something into a perfect square, so that then you can factor it and have something like what we have on the right side here. So this example is one that requires us being able to complete the square. And the steps to follow are to, first of all, group the x terms together and the y terms together and have any constant on the right side of the equal sign. So if I do that, here are my x terms. So I have 4x squared minus 24x. Then I'm going to look at my y terms, so plus 25y squared plus 100y equals, and I want that 36 not on the left side, so I'll subtract 36 from both sides. So I've got a negative 36. Now I'm going to take a look at, first of all, just the x part. Okay, and I want the coefficient of x squared to be 1. So I'm going to common factor a 4 out of that pair of numbers. So I'm going to pull 4 out, divide each term by 4, so that gives me 4 times x squared minus 6x. Likewise with the y's, I'm going to do the same thing. So I'm going to factor out 25 from both of those terms. So that's 25 times y squared plus 4y equals negative 36. Okay? At any point, you should be able to reverse your operations and get back to the line before. So you can always check that what you're doing is still legal. Okay? Here comes the fun part. Now I'm going to complete the square on each of those pieces that's in brackets. Okay? So I've got 4 times x squared minus 6x. Think of what number do I need to add there to make that piece in brackets be a perfect square. Half of 6 is 3, and 3 squared gives me 9, so I'm going to add 9 here. Likewise, for the y's, I've got 25 times y squared plus 4y. What do I need to add to that to make a perfect square? Half of 4 is 2, and 2 squared is 4, so I'm going to add a 4 there. Equals. Now, I've added a bunch of things to the left side of the equal sign. I need to add the same things to the right side of the equal sign. So I still have a negative 36 on the right. If you go back and think about what we added, adding that 9, because that 4 is outside the brackets and multiplied by everything in there, I've really added 4 times 9. So I have to add a 36 on this side as well. I added this 4 here, but that 4 is multiplied by 25 outside the brackets. So really I've added 25 times 4, so I need to add 100 on the right side. Now everything I've done to the left has been balanced by doing these two, adding these two numbers on the right. So now we can simplify both sides here. So x squared minus 6x plus 9 is really x minus 3 squared. And y squared plus 4y plus 4 is really y plus 2 squared. And on the right side of the equal sign, I've got negative 36 plus 100. I've got 100. So now this is almost in standard form. I can just take each term on both sides of the equal sign now, divide everything by 100, and I have x minus 3 squared over 25 plus y plus 2 squared over 4 equals 1. So now it's in standard form. I can see that my a squared term is 25. My b squared term is 4. I can see that the center of this ellipse is going to be at positive 3, negative 2. I could calculate the value of c and quickly sketch that graph as well. So that is a tricky skill that is one that needs a little bit of practice to be able to complete that square and to keep track of all of the steps. There's another very good example of doing this in the textbook as well. And that's it for this lesson.